So I would like to welcome everyone to the April 2023 MAS General Meeting. Hello, everybody at home and everybody in-house. Thank you for coming. I do have a picture that I stole from Doug Neverman on the Astrophotography Slack channel, which thanks, Doug, I didn't tell you. But it is his and the Great Barred Spiral Galaxy, NGC 1365. I thought it was pretty cool. I think he did that in a remote observatory. So I think it turned out pretty well. But I will be, sorry for the ums, I will be going to be keeping this meeting very short tonight because we have a lot of things to get through and a couple of wonderfully interesting presentations. So we'll just carry on and see who's with the board. There's me, there's John Zimmich, who is our tech support tonight. And Dave Faulkner is in the house as well. Yay. Matt is out of town. Conrad, not sure if he's online, and then Ahmed, who is also online tonight. So welcome everybody. And welcome new members. We have 17 new members through the month of March. Yes. So welcome. Anybody in-house that is new? Hello, welcome. And what's your name? Hi, Carolyn, welcome. And Dick Haynes, well, welcome. Oh, okay. Glad you were able to make it tonight. Appreciate that. Oh, and?
Frank Kunstler.
Hello.
I just got on space. So.
We'll say hi to you again in next month.
Okay.
So come again, come back inside. And for all of you new people that are online, welcome. I also appreciate you joining our club and supporting us in our crazy adventurous hobby. And anything else that we can do to help you, please let us know. I appreciate that, which does bring our total up to 695 total members. So we're growing, we're growing. Hopefully we are providing you with the same services that you hope from the club. If not, give us a, send us an email. We'll find out and try and help you out. Yeah, it's on the secretary at mnastro.org. We'd love to answer your questions or info, that one too. I think that's just a little comment picture from Mark. So, and then we have Loner Scope program, which I'm assuming that Anton's online tonight. Hopefully he can unmute. I'm not sure. I forgot to check. Sorry. He's not online. Guess, John, you're up. Tell us all about the Loner Scope program once you get the microphone going.
Okay.
And you have to come up here and stand in front of the camera.
That's right. I forgot about the camera.
Please.
Hey, yippee. But yeah, the Loner Scope program is actually doing really well right now. We has a couple scopes out for the winter, but as you all know, Loner Scope program kind of slows down during the winter. So we're getting everything geared up for the year. We have we added a new scope over the winter, another 8-inch CSE, and then we are bringing in another 8-inch Dob. So, which is, those two are the most popular of all the scopes that we have. So, and they're checked out all the time. So that'll be nice that we're going to be adding, and we're going to be, we have 16. And so yeah, adding that other Dob will bring us up to 17. We're looking for, we had one 8-inch scope that got damaged. We're looking at replacing that one. So, and we're looking for an 8 CSE. So if anybody has a line on one or can, let us know. We're looking for kind of a used one. We're looking for that ballpark $800-900 that we'd like to spend on it. So something used, but that's the Loner Scope program is looking really good right now.
And how do they find that on the
and
website?
That's right on the web page. There's a Loner Scope program page. You can see all the scopes that are available and then check them out. You just fill out the form and that'll go to Anton, who runs the program, and then he'll coordinate the pickup and the drop off. And it's a 30-day, 1 month checkout. And if nobody else is requesting the scope the following month, you can have it another month, but then you have to turn it in after that, and then you can check it out again the next time it's available. But the 8-inch CSEs and Dobbs, those you probably are going to only get for 1 month. Any other
Very
questions?
popular. And we have the DVDs too, the great courses.
Yes.
How many of those do we have?
I don't remember offhand how many, but if you look at on the website, you'll be able to see, and DVDs, they're excellent.
Mm-hmm.
You can check those out as well.
Anton
has people come to his house.
Actually, yes, it's worked out really well. We have a storage facility for the loaner scopes, but for the most part, especially when it's really active, things aren't sitting in storage. They're out, and he works out of his house out in Vadnais Heights, and so you just go there and pick them up and drop them off. So it looks like he's running a business or some strange thing out of his house and driveway. He was asked by his neighbors when he started doing that more and more, rather than going to the storage shed and meeting people there, which it isn't that far from his house, but it's really convenient that he's at his house.
Mm-hmm. Mm-hmm. Excellent. Thank you. Thank you, John. Appreciate that. Yeah, that's how I first started in astronomy here. I borrowed telescopes. It's beautiful. I love it. COVID, of course. I think we're in the post-COVID age, so that's why I changed our heading a little bit. That masks are still okay if you need to wear them. If not, it's totally fine as well. I know the one of the health facilities issued a statement either yesterday or today that they were dropping all mask mandates unless it's for high-risk areas of their hospital. At the Mayo Clinic, thank you. But you know, as always, if you don't feel good, please stay home. It's always better for you to stay home and rest and get well quicker so you can get out and observe at night. It's just, you need to be out there. Sorry, I'm getting a little anxious. I need to be out underneath the stars. And that also goes for our sites and stuff too. I think there was some question about it earlier that just a refresher that you don't have to post on the website, but it's very highly requested that you still do the ISPs, even though you don't have to. But even out at, star parties, ISPs, that kind of thing, you feel free to wear a mask if you're more comfortable doing that, and or not. It's up to you. We generally don't have any other restrictions anymore throughout the club. And if you do have questions about it, feel free to drop us a line at info@mnastro.org and we'll answer your questions. Thank you. Sorry. You got to be here in person for all the heckling that I'm getting in the back end behind the camera. So I apologize for all the giggling. And Jerry's in the house too. So we'll get, thank you, Jerry. I love you too. Great thing that this is recorded, right? For the month of April, we have some interesting events. Always the full moon, which was last night, but that's okay. You can still get out and see it. A couple of conjunctions, or a Jupiter conjunction, and then the Lyrid meteor shower. Looking forward to seeing those shooting stars. I know, not appropriate, but it's okay. And then I just wonder how many want to go to or are going to go to the hybrid solar eclipse. So if anybody is going to Western Australia, sorry, John, not that one, which is the only place you can see this one, which apparently, according to Google, is a rare solar eclipse that changes from annular to total and or vice versa along its path. And that's in Northwest Cape Peninsula of Western Australia. So if anybody does go, I would love to have a little presentation at some point up here, instead of better know a constellation, we can say better know an annular eclipse. I'd love to see that. Upcoming star parties. We have so many. Yes, Jerry?
Is Bill Glass on?
Possibly.
If he's there, maybe you could ask him if he's going. Is it any in the club for going to that eclipse, it would be Bill.
Okay. The in-house question was if Bill Glass is going to the Western Australia eclipse.
This is Bill.
Yes.
I'm not going. Sorry. Wish I could.
Washington, devastated.
Yep, yep. Well, there goes our one potential, person. So that's okay, Bill. Maybe for the next one, you can still, give us a little review. I'd appreciate it.
Okay, well, the next one's in the US in a year.
That's true. Yeah.
So April 8th next year.
I think a lot of people will have some presentations on that one. Not me, because I do presentations every single month. So I'm going to leave the floor to somebody else on that one. Looking forward to it. Thank you, Bill. The upcoming star parties, which so we can't get to the eclipse, but we can go to the star parties. There is one at ELO this weekend. They are the public star parties. And then on the 25th in Norwood Young America, and Cedar Creek Ecosystems, or Ecoscience System. Yes. No, all right. So it was a late night when I was doing my dates. Apologize. Probably. Okay, so Cedar Creek is the 29th? No, sorry. Oh. Why did I? Okay. You know what? Look at mnastro.org for the latest and greatest on public star parties, pretty please. It's your best source of information. Don't listen to me. But Cedar Creek, we do have a star party coming up on April 28th. I have that one correct. But we also have little postcards that Cedar Creek did for us because we are helping host those events. And there's some postcards on the free table along with some books back there for anybody that's in the house. That's cool. And then we have the BSIG. There's some discussion in here about the dates. But the Messier Marathon that is coming up for CGO. Oh, and now. Okay, the BSIG is the 29th. Okay. Suresh, do you want to come up here and talk about the BSIG before I go on to something else? And tell us what we're watching or looking for in that night, provided it's not clouded out in anything else. Your camera's right here.
Oh, right
Aren't
here.
you glad you're going to be on camera?
Great.
See, there's your little face.
All right. Just real fast. So we're hoping to have our first BSIG, outdoor BSIG session of the year this month. Depends on how quickly the snow melts and the ground dries out. But we're aiming for Saturday, April 29th, with the backup being the Friday, the 28th. We make the call based on the weather forecast as we get closer. And so this time of year, it's really about the galaxies. There aren't a whole lot of planets out right now. We can catch Venus after dark, and then Mars will be, I think, high up in the south right after dark. But none of the other planets are out in the evening sky right now. So it really will be all about galaxies. So we'll spend a lot of time perusing the Virgo cluster and up in Ursa Major, where you've got like the Whirlpool Galaxy and the Pinwheel Galaxy and things like that. So we'll start right around 7:30, assuming that the ground clears out and we're able to do it. So any questions about it, or if you have any comments, and I'll answer for you.
The 28th is the secondary.
Yeah, we do it in reverse. The 29th is the primary and the 28th is the secondary.
Cedar Creek is primary is Friday, backup is Saturday, so it's flip flop.
Yeah.
We just like to confuse people.
Yeah.
We're going off the website. Check it out.
So
All right, thanks.
thanks, guys.
Thank you, Suresh. I appreciate that. And of course, the Messier Marathon, CGO, call or no call, or go, no go call will be done by either Jerry Jones or Chris Setness. And Dave Faulkner will be hosting it along with some key holder training on that particular night as well. I'm going to be out of town, so it's going to be his joyful duty to do so. And then the LLCC star parties have started. So just check the forum for those dates and sign up on the forums that you're indicated of going. That way the rooms are reserved. Any questions? Let Ken know. Gemini articles, always need them. The Gemini actually just did publish, and that is online as well. And it's also through the MAS happenings. Sorry about that. But Father Brown has sent him some articles about anything and everything, and he'd love to publish those. And I believe the next deadline is May 10th. And then it's published by the end of May, beginning of June. Yeah. Which brings us to the MAS happenings. Yes, Suresh?
Sign up for Northern Lights Star Fest is open. I don't know if there's been any announcements about that, but you can sign up for Northern Lights. The dates are August 16th to the 20th. I don't know.
Microphone.
Sorry.
People at home can't hear you.
Sorry, just so people know, Northern Lights Star Station itself this week. I haven't seen an announcement for that, so I just want to let people know. I don't know where the link is. Is it on the?
It hasn't been posted.
It hasn't been posted yet. Yeah.
Okay, yeah, so keep an eye out for that. If you're interested, the dates are August 16th to the 20th.
Okay. Thank you. Yep. Nope. I have not gotten any updates about that. So we'll check with Ken and get that perhaps published in the next happenings or something. That's all I have. Astronomical League Awards. Mr. Jerry Jones usually takes care of this. He is being shy tonight, even though he's in house.
I ain't got nothing. You're
There isn't anything here.
Gee, funny. I haven't received anything from anyone in weeks. So the moral of that story is get out there and observe.
My favorite part of all of your talk about it. And if those at home or new that don't know what the Astronomical League Awards are, is they are observing programs that help you if you need to have somewhere to focus on the sky you're exploring. You can start with the Messier list. You can start with sun spotters if you wanted to do something during the daytime, sorry. And it has certain criteria that you need to fill, and it's very well spelled out. And by the time you get done, you get to have a certificate and a pin that goes along with that award. They're very cute. They go on a lanyard, which Jerry's not wearing his tonight. I forgot mine at home, but they're really cute little pins, and they get very heavy though. So you might want a vest by the time you get all of them done. But I would just go out to the AL League, alleagueawards.org. I think that's the website. Get in touch. We'll help you out. And then up next we have Ahmed, which, pardon us while we get stuff. I have to stop sharing so that way he can share. And we are going to talk about an impromptu. Ahmed, I believe you can share your screen now. He's going to run us through. Yep, he's going to run us through some impromptu Star Party site reservation system that's brand new. Take it away.
Can you see my screen, Trina?
We see it.
Yes, we
Okay.
can.
Perfect. Thanks, everybody. So the objective of this, and I'll try to make it brief because we got great talks after this, but pretty much the objective is for key holders to reserve sites at ELO, reserve the site at ELO, at CGO, and at JJC for their own observing. And pretty much we used to have a reservation calendar, and then before COVID, it fell apart. And for years, we've been running sort of like a makeshift reservation, unwritten procedure off of the forum. This is intended to replace all of that. And my last slide, I'll talk about the implementation, how the pilot is going to work. But first, I want to actually share with everybody how this is working. So the first thing is to access the calendar, reservation calendar. It's off of the website. You go under facilities, you can highlight Eagle Lake or Cherry Grove or JJC, and then you'll see there is a key holder reservation link. Now that link is going to be password protected, so not anybody can just jump on it and reserve a site. And the ones with access to that password are going to be the key holders, and that will be posted on the specific site key holder forum for the key holders to access and utilize the calendar. So when you click on the key holder reservation link, That will take you to a login screen. When you have the password, you just type it in there, and then that will take you into the reservation calendar. So now pretty much the guidelines around using this is that, again, this is for key holders of those sites who are in good standing. They may reserve the equipment and the facility for whether, outreach events or, their individual star parties or imaging or whatever they want to do out there. So, and then the second thing, this is only for reserving telescopes. If you want to be on the site ground, like for example, on the ELO Plaza, just doing your own imaging, you don't need to do a reservation. This is, let's say, if you're out in ELO and you want to book, the Sylvia Casby telescope and observatory, then yes, you go and use that. If you want to book the imaging or the visual rig, you do that. But if you're just out on the plaza doing imaging, don't need to do any of that. And then the second thing, this can only be utilized by key holders. And as I said, it's going to be behind a password protected page. And for example, the ELO one will be on the ELO forum, the CGO one will be on the CGO forum, etc. Now, when you book, you're going to be getting an email notification to your phone, and we'll go through how you're going to be putting in your information. You're going to get an email notification, and then that pretty much, that email notification is an invite that you can accept, and you can access, whether it's an Apple or an Android phone on your computer, whether you use Outlook or Google or any email, you'll be able to access that, and that's on your calendar. And that becomes actually important because later you can actually use that to cancel the asset if need be. The other thing is that members reserving assets, they need to make sure that they keep the reservation up to date. If they need to cancel, they need to cancel and free up that asset, free up that telescope for others to reserve it and use it. If you book assets and you don't use it, it doesn't serve any of us well, because then, we're not utilizing the equipment. It's self-explanatory. And then when it comes to utilizing the equipment itself, people need to follow the site guidelines. This is just a reservation calendar. So if a specific site has a specific procedure for using the equipment a certain way, you need to adhere to that. And then work parties, which are an important aspect of any of our sites for the upkeep, maintenance, and making sure that they're always in a good shape, and as we upgrade them on our regular cases, they don't need to do a reservation. As work parties, they do their work during the daytime and they don't do their work at night. This is for reservation throughout the night. Now, if there is a piece of equipment down or they need to calibrate or align a piece of equipment at night, then there'll be notifications posted, and probably we're going to be blocking that asset so you don't have access to it to reserve it. And you'll know in that case. The other thing is that, so we plan to get work parties completed between 8 in the morning and 4 p.m. And that's the time they're not going to be reserving that. So expect people to be out there during the day. And again, this is a reservation calendar for the nighttime. And then the work party volunteers will make sure that the equipment or whatever they were working on is in an operational state after they complete the work party, so that whoever is reserving the asset doesn't have to worry about going out there in advance to do cleanup or to change anything in the setup or prep anything. They just need to go out, reserve the asset, go out there and enjoy. Now, it's still highly recommended. If you know of a work party going out there and you're a key holder, go and volunteer and go and help them. You become much more familiar with the equipment and you participate in growing our community and contributing to the club. And then, last but not least, this is, again, this is a reservation calendar. Make sure that you need to adhere to the facility shutdown and checklist completion and following the procedures, and making sure that you coordinate with other key holders on site when you're out there. So, and we'll talk about, in a little bit, if there are others who have assets reserved, how do you get their contact info, etc. But pretty much when you're out there, talk to others. For example, if you're at ELO and you're observing at Sylvia and somebody's at Onan, and you shut down Sylvia and you're about to leave, but the person in Onan is still there, make sure you talk to them, make sure you coordinate to them, follow the checklists, for shutdown. And if push comes to shove and you need help, call any of the directors of the facilities for help. So these are just high level the guidelines. Now, when you log in, you're going to see this calendar here, and pretty much this calendar, yeah, you can see the check boxes up there. You can actually hide some of those details or show them. It's up to you. Preferably show them so that you know who else is out there. But the details are broken down into 3 categories. The first one, other key holder reservations. As you can see who's got the, you know, what piece of equipment reserved on what day. And also you can see the phases of the moon, especially if you're doing imaging, that's probably important for you. And then you can also see other MES events on that calendar. Now, if you hover over any of the other key holder reservations, you should be able to see the details of that person, their email and their phone number. And if you plan to be out there for another piece of equipment and you're wondering about, hey, I was also thinking about this piece of equipment, like, okay, I'm out at ELO using the visual rig, but I saw Volts has this, you know, has Sylvia reserved, and I was wondering if him and I can share, then feel free to talk to your fellow MES member. Again, we cooperate here and work together, and Volts might say, hey, you know, you can use this, and he might say, no, I'm going to be imaging all night and I can't tear down my setup. That's okay. So again, talk to the others out there and contact them. And then the other, so after the calendar, you scroll down, you're going to see a section that actually has the actual equipment that's out for you to reserve. You don't have to be worried about if public events that are out there. So public start parties at ELO, for example, those calendar days are not going to be available for reservation. And as you can see, every site is broken down to assets to maximize the number of people who are actually utilizing it. So when you're booking, you're only booking like Sylvia or the visual platform or the Meet LX200. And so in each one of those, when you reserve it and cancel it, it's independent of the other. You might decide, hey, I'm going to book, you know, the Obsession telescope and the imaging platform for that night, and then decide you want to cancel one but keep the other. You can do that, or you can cancel both, or you can even add a later, you know, you can decide, hey, later I want to add the Meet LX200 to my list. You can also do that. So you can book more than one at the same time and do that. So the scheduling is pretty straightforward. You click on whichever asset you want, and that will take you to the calendar, and then it will show you that next screen. What are you booking? And some high-level description for it. And again, the reservation starts at 4 p.m. the evening of the day you're reserving, and then it goes through midnight until 8 a.m. So you don't have to pick the time saying, hey, I'm booking from this time to that time. No, it's a fixed time slot that you get when you do that reservation. So you pick the day, you select the date, and then pretty much you select the time. It's all fixed. Just click on that calendar, and then it will take you to the important, you know, section where the important screen where you actually put in your information. And it would be good to put what the you know, what are you doing from a purpose standpoint? You know, is this outreach or an individual star party? Or, you know, for example, if a piece of equipment is down, this is probably where we're going to block it and say, you know, this piece of equipment is down and we're like aligning it or something. We'll be putting that detail in the reservation purpose. So you put in the information and then you click book. And after that, that pretty much takes you to, pops up another screen saying, okay, you know, your reservation is confirmed. It will send you an email notification. That's the one with the calendar invite that you can save. Also, you can use that window to cancel your reservation. At this point, if you went through all of this and said, you know what, I want to cancel it, you can cancel it here. Or you could also decline the calendar invite that you get in your email. And pretty much if you decide to cancel, because this is the part that we still haven't fully automated yet, so it might take up to 48 hours for it to go off the calendar. Volts and I are going to be on top of it. You should be able to see it within a couple hours. So pretty much you go, after you hit OK on that, it takes you back to the calendar. You refresh that screen and you can see where your reservation is. It's going to show up on the calendar. For example, here you can see I booked, you know, Sylvia Casby at that specific time. And again, if you hover over it, you'll see my details, etc. So this is the reservation, the email notification. As you can see, there are two places on that email to cancel the appointment or decline the invite. Both of them will yield the same result of canceling your reservation. And then last but not least, at the bottom of the calendar, if you have any questions, if you have any recommendations, how can we help? How can we make this better? There's a form, fill it out, or a specific issue regarding reservation. Go ahead and do that. It'd be good to actually point out what that date was so that we can actually keep improving this and fix any bugs that we come across. Any questions so far? And I still have one slide after this regarding implementation.
Okay, this is Dave Faulkner. With ELO especially, you might have people who have reserved two different telescopes within ONAN. Okay, one might be doing visual, one might be doing imaging, for instance. I'm assuming that the expectation is that whoever's last at the observatory will be responsible for closing it up and doing the checklist.
Absolutely, yes. As I said, Dave, again, people have to adhere to the requirements for operating the equipment, the procedures to follow when they're out there. And yes, the checklist is one of those mandatory procedures that people need to do when they're shut down. And in that case, yes, my understanding, per the ELO procedure, whoever's last on site needs to make sure that they do the checklist, they do the walk around, make sure that the facility is in a good shape before they leave.
Hi, it's Suresh. How do we go about getting passwords? Who do we talk to?
So the password will be shared between each site key holders, and it will reside on the forum for each of those sites.
So we don't have individual passwords? There's going to be
We don't have an individual. The password is just to get you into the reservation calendar. You will need to use your personal information to do the reservation. The password is just to give you access into the system.
As a new person, if you want to participate in a work party, how do you know when they are and how do you do that?
Work parties are posted on the forums for each of the sites. So ELO has its own, site. They'd be posted there. Some work parties require that, hey, we need key holders for them because it's intricate, work that has to deal with the equipment. Some can just be a work party. Hey, we need help just cleaning the site, for example, or shoveling snow or whatever it is.
Okay. Yep. Yep. And to get into the forums, if you haven't registered before, it's an easy registration. It doesn't collect any personal information, but at that point, then you can go through some of the top board menu items or board items, and then get to the different sites. And that one will be Eagle Lake Observatory discussion forum. And then it will have the work party situated on there. Yep.
And Trina, earlier you shared that there is the training day for key holders for CGO. And also in May, there will be the training for ELO. A couple of them.
That's correct. I believe it's one of the first, second, May 13th and 20th.
Hey, Ahmed, for CGO, is the BAD going to be on that sign up?
Yes.
Once we get the wheels on it and we get those problems figured out, yes.
Yep.
Yeah, we're getting there.
Yeah.
We have one wheel out of all of one wheel that's given us a little bit of an issue. That's okay. It's okay. Dick Jacobson is doing a great, phenomenal job, and we appreciate it. And it should, hoping it will be ready before the Messier Marathon. If not, it'll be interesting. So, all right. Any other questions online or in-house? Oh, go ahead.
Okay, go to implementation.
Correct.
Okay, perfect. So the way we plan to roll this out is by Monday, we'll have the posts on the forums with the passwords. The slide deck will be there for your reference. And this will be the beginning of our pilot period, if you want to call it. And then our pilot will run until the June monthly meeting. And our objective during that pilot is work out any kinks. And so during that time, we want people to start going out there and using the reservation calendar, but also posting to the forum. So we're gonna actually ask people to do it in both places just for this duration of time. And I'm gonna be getting on the forums and asking people with previous reservations, during the pilot period to go in there and get on the calendar and book things. But we're gonna be running a hybrid system here for almost a 2-month period just to get people used to it, work out the kinks, and then hopefully June 1st, we have all the issues resolved, and then we do a full transition to the reservation calendar and no more forum posting for reservations. Fair enough? Any questions regarding that?
I don't think so. I only have one further statement about CGO because it's I have a key holder forum for CGO, but it's not active with any key holders yet. So in the meantime, if you have something that's along that line, perhaps email mas-cgo@mnastro.org for, just an update, a quick heads up that, hey, I want to do this. Or no, to ask for the password. Sorry, to ask for the password. So, okay.
Sounds good.
Thank you, Ahmed. Any other questions? Perfect. Well, guess what, everybody? We have John himself in-house is going to do the get better know a constellation.
Okay, so actually, I'm doing the Better Know a Constellation. Oh, this is fine. I'm doing it on Canis Venatici, but you'll notice this picture here is the Coma Galaxy cluster. The reason for that is Michael Rogowski, I asked him, because I was initially going to do Coma Berenices for my presentation, and he posted this beautiful shot. He took this image and it fit right into my presentation. Well, then my May issue of Sky and Telescope showed up, and the feature article was Coma Berenices that contained a lot of the information that I was going to present, but I couldn't resist throwing this up there. So what I decided to do was move next door. I just hopped next door over to Canis Venatici. And is it page or arrow?
He's hijacking my computer. There.
Okay,
How many different ways can anybody?
thank you. This is another slide I kept because John Flamsteed's Atlas edition 1729 had Coma Berenices on it, but I could just hop over there and do Canis Venatici. So you can see that the constellations are really close to each other, and there it is with Boötes and right next to Ursa Major. There's just some notable facts about this. Ptolemy didn't actually have Canis Venatici. This constellation did not exist in the Almagest. He considered these stars just random stars below the tail of the Great Bear. Okay, and so what happened with these stars? The constellation actually originated from a couple of mistranslations. In his Almagest, he had Boötes with a club, and Coloribus is the Greek word for club. Well, when the Arabs were translating the Almagest, the Arab translator mistranslated club to staff with hook, and hook is kulab. Okay, so now we got a staff with a hook. And then the Latin translators came along in about the year, 1400, around there, 1500. And the Latin translator mistranslated hook, which is kulab, to kilab, which is dogs. And I'm not an expert on Arabic, but there are diacritics. Those are, if you ever look at Arabic writing, it has a lot of little dots and dashes, umlauts, kind of things like on Boötes there, things like that. Well, when they're writing, sometimes those can be omitted. And I guess Kulab and Kilab look very much alike. So all of a sudden now we have dogs. Well, it was in 1533 that the German astronomer Peter Apian first introduced an atlas with Boötes pictured with dogs. And then it was formally introduced by a Polish astronomer, Johannes Hevelius, in 1687 in his atlas. And then the International Astronomical Union, when they're setting up the constellations and all the borders and boundaries, they decided to make it formal. And guess what? We have dogs. Well, you know, going from Ptolemy, where it's some stuff under a bear's tail, it's kind of fortunate that we ended up with dogs. So otherwise, who knows what we'd be looking for out there in that area of the sky. And this is where it is. And it's very interesting part of the sky in that if you'll notice, if you're familiar with star atlases, see those little pink reddish kind of things, ovals and circles, those are all galaxies. And there's a reason there's so many of those here. And in fact, there's 5 Messier objects in Canis Venatici, and there's one is a globular cluster, the rest are galaxies. And the reason for that is right about, I don't know what I'm looking at. Am I over here? I'm on it. No. No, that's all right. I won't worry about it. But if you look down there at Coma Berenices, the angle, then to the right of the corner star, which is Beta, Coma Berenices, there's the 2 stars. Just below those 2 stars. Oh, thank you very much. Oh, why didn't I? You were right on it. I'll just use this.
Yeah, you got to be on this screen for people.
I was trying to get this one over there, but it wouldn't go. But yeah, so thank you. So right in here, that's the galactic North Pole, right in this area. And so we're looking at the top of our galaxies. We're not looking through all the clouds and other objects, the center of the galaxy through the arms. So we have a nice clear shot outside the galaxy. So we can see, millions, hundreds of millions of light years. There's, with very little to obscure. So that's why there's so many galaxies out in this area. And in fact, that Coma cluster is just to the left of those 2 stars on here. It's right about there. But so that's the area of the sky that we're talking about. So what kind of objects are out there? Well, guess what? There's galaxies. But I'll start with a star. Cor Caroli. And Cor Caroli is the brightest star in the constellation. It's about magnitude 3. It's about 110 light years away. And the name means heart of Charles. Okay. And this is one, there's a few objects in the sky that are actually named after real people. Coma Berenices is one of them. Coma Berenices. Berenices was the wife of the emperor of Egypt. Guess what? A guy named Ptolemy. Not the guy who made the Almagest, but these Ptolemies in Egypt are kind of like Johns and running around here. Everywhere you turn, there's a Ptolemy. And anybody who did anything, their name was Ptolemy. I mean, Cleopatra's dad, guess what his name was? Ptolemy, yep. But this one here, guess what? It's not a Ptolemy. A Ptolemy doesn't have anything to do with this. This is a court physician saw that Cor Caroli shone with extra brightness on the return of the king from a battle in France. It was actually the son of the king. The King Charles I was actually captured and killed. And if you ask the British, he was martyred. And his son returned, and on the eve of his son returning, on May 29th, 1660, the star shone bright. Well, whether true or not, if the myth outweighs the fact, you go with the myth. Okay, so that's what we do. And Cora Caroli is a binary star, and it's a very beautiful picture up there by guy Jeremy Perez, and he does depicted that double star really well. So that's what it'll look like in your scope. Now, the primary star has an overabundance of europium, mercury, and silicon. And what that results in is a very high magnetic field around that primary star. But this guy is in the double star SAL observing program if you're interested in looking at those. Yes. And this is what it looks like. This would be kind of this. I use as an example for most of these my 8-inch Celestron, and you can see where the constellation is. It's if you draw a line kind of between Alkaid up here in the Big Dipper and the nebula, the tail of the Leo, the lion down here, and it's about a third of the way down, from Alkaid, and it'll be the bright star sitting right there. And that's kind of what it'll end up looking like. That's at 254 power. Then we hop over to the globular cluster, the Messier object M3. It's one of the brightest globulars in the sky. It has about 34,000 stars, or excuse me, 34,000 light years away, and about 500,000 stars. And I put my observing notes up here, and my 15 by 70 binoculars. It was very easy to find the bright globular cluster. Has a very bright center, and I can resolve stars around the edges. Now in my C8, had a very bright central area that gradually faded out to the edges, and I can resolve many stars using my 12 millimeter. And this guy is in the globular cluster Messier and urban programs. And that's where it's located, just to the east of Beta Coma Berenices, and so northwest of Arcturus. And that's sort of how it looked in my my 12 millimeter. Then we go to this is one of those superstar ones, M51. A beautiful galaxy. It's an SC, which means it's a spiral galaxy. The C means that the arms are kind of loose, wrapping around the spiral, and it's interfacing with a dwarf galaxy. And this was discovered by Charles Messier in 1773 using a 3.3-inch scope. And in my 15 by 70 binoculars, I could easily see the main galaxy and the smaller partner, a fuzzy oval, but I couldn't really see the connection between the two. But when I got to the 8-inch, they were both large objects. I could easily see the companion galaxy. I could break out some sort of modeling detailing the arms, and I could actually I could see the arm connecting to the partner galaxy. And this is in the ARP North, the Messier, the Sketch, and the Universe Sampler programs. This gives an idea where it is. You can see there that it's just southwest of Alkaid, not very far, so pretty easy to find from that reference point. And in my C8 with that 20 millimeter, that shows kind of the relationship of the galaxy with the little dwarf galaxy partner there. Then we moved to M63, the sunflower. This is an SBC, and you have to be kind of careful when you say SBC, because if it's a capital B, it's a totally different meaning than a small b. What a capital B would be a barred spiral. This SBC, it's a spiral galaxy, and BC means that it's intermediate between a moderate and a loosely wrapped arms around the core. And my 8-inch, I could see this thing very easily, finding it in my 55. With the 20 millimeter, it was asymmetrical, slight point on the right side, and it was somewhat modeled. This one is in the Messier program. And where this one is, just north of 20 Canaan Venaticum and Venaticorum, I'm sorry. And it's, within the finder view on my scope. So it's actually fairly easy to find from that reference point. The magnification for this picture here, that one is 102 power. So that's my 20 millimeter in there, which gives me 100. Then we go to something that I haven't seen yet. This is IC 883, so this is going to be a bit more challenging. It's in the ARP, well, it's ARP 193, a regular galaxy, has twin tidal tails, which are thought to be the remnants of two flat galaxies that collided. There's lots of star formation activity going on in that central core. If I could see this, it'd be very challenging in my 8. I'd probably only see that very bright piece in there. It's difficult in the 14. You probably need to image in order to get any of the wisps going out from those spiral arms, or what's left of them. This is pretty much the core that you're going to see. And this one is in the ARP North observing program. And then this example here would be what we'd see in the 14, and say at ELO. And you can see it's north, the galaxy is north of Beta Coma Berenices. And kind of, if you make a nice little triangle between Cor Caroli and Beta Coma Berenices, it'll just be nice off to the west there. And you can see it's even in the 14, it's going to be pretty small object. But if you're working on that ARP program, that'd be a good one. And this one here, I'm surprised I hadn't looked at this thing. I don't remember ever looking at this thing before when I was looking, putting this together. Because carbon stars are beautiful if you've done any of those programs or looked at them, because they're nice red stars. The thing that this is named La Superba, this really has to be something. But and carbon stars are unique because of their spectrum and their high carbon. Most of them are red giants. La Superba is. It's a class C5JN3. The J makes it a rare form of carbon star in that it has it's carbon 13. It's a stable isotope, but it has an extra neutron thrown in. And but it's one of the reddest stars known and among one of the brightest. So I'm going to actually search this one down. And it's also a variable star that varies about 2.5 magnitude over 160 days. And this guy's in the carbon star, the binocular variable star, and stellar evolution programs. And that's where it is in the sky. You can see it's kind of between Beta Coma Berenices, which is off to the left of Cor Caroli, and Al-Qaeda. And since I've been talking a little bit about observing programs, but this is an idea of what you can find in Canis Venatici. And you'll notice, just as far as the numbers up there, the majority of those are galaxies, just like I started out with. There's a couple other objects thrown in there just for fun, I guess. But the majority of those you're going to see are galaxies. And there's a number of images as well that you can do visual or imaging observing program projects. So if you want to get out there, observe or image. Thank you. Are there any questions? No, not yet. I'm working on much simpler stuff.
Do you know what's
The question
what's
was, am I
ARP?
doing ARP North? And I said, no, I'm working on much simpler. Good grief, I'm trying to get the Messier done and I just blew it. I was talking about that M79, which is in Lepus. It just disappeared and I missed it all winter. Cloudy sky and whatever, cold.
Oh, am I on? Okay, I just had a question. Some of those lines had imaging or viewing, and then some of them didn't have anything. What are the ones that didn't have an entry?
I'm sorry, if they didn't have an entry on that slide, that, Trina, if you can back up one, there you go.
One?
Yeah, if it didn't have anything there, that was just visual. The AL programs, this is probably more of a Jerry subject, but I'll go here. The AL programs were all visual programs since the inception. And it was, I don't know how many years ago, Jerry, did they start adding imaging?
7, 10,
But-
something like that.
Okay, 7-10 years ago, and it's more and more. I've just noticed that over the years that they're including imaging in more and more of the programs. And I guess it reflects on how popular imaging is in, members of the organization, and as
Yep.
far as this organization as well.
Right, and there's actually a few that can be one or the other, and you can get 2 different certificates for it if you complete one or the other. Kind of like the Sunspotter one, where you can do visual and then you can do the hydrogen alpha and get 2 different certificates, but only 1 pin. Yes, you are. There's so many I do not know, Jerry. This is your thing.
Do you have a question or? No, that's not.
Where did you take the big one?
Oh, the pictures that you see, yeah, those are all, I wish they were my images, but no. These, I got these off all online. Most of the galaxy shots are, Hubble or observatory, professional observatory. This one here, I think was just a person shot this one, Lessa Perva, and Corcaroli. That was drawn, that was a sketch by someone. Oh, what's this rush question?
Hey, John, I forget these big galaxies that are in Canis Venatici, are they Virgo cluster galaxies or are they outside of that?
Yeah, they're outside of that. You
Outside
have
of
some of them, I think, are in the coma cluster, which I don't know if I don't know officially if coma is part of Virgo cluster in a big scale or not. I think it's, yeah. Yes. Yes.
Mhm. I don't know if there's any questions online. I need to look. No?
Okay.
Okay.
Thank you.
All right. Thank you. Thank you. All right, real quick before we go into our guest speaker for tonight. Our next meeting is May 5th. Yes, I know. At the Unbetuteka Education Center here in Roseville. What? I've been practicing because it's a hard language to get wrapped around. And that in May, it will be our featured speaker will be Professor Stephen Spangler from the University of Iowa. Topic, unless it changes, on talking about Venus, which is the Earth's twin. And Claire might know some of the people that he's with his astronomy group, because I think it's the one that I think so. Yes, we'll have to touch base with Ahmed, but yeah, I think it's with the Cedar Rapids. Outside of Cedar Rapids. Yep. Okay. So with that, I would like to stop sharing my screen and introduce for you Chuck Allen, who is going to be talking about extreme astronomy. And Chuck, you may share your screen if you wish. And the presentation will examine telescopes, space travel, planets, moons, mountains, stars, galaxies, clusters, black holes, and the quest to find the largest, highest, closest, furthest, hottest, coldest, most massive, brightest, and darkest among these various objects, and many firsts among astronomical discoveries and accomplishments. And I got that all from Ahmed's page. So I did not practice. It was just flowing. So, Chuck, are you able to, you should be able to share your screen at this.
Okay, first of all, I want to say that I wanted to say a few things about the league before we begin. First of all, the bylaws have passed almost unanimously, and only one objection to one little part, and we've corrected that. There's been one of the major changes is a voting rebalance. All the independent members of the league, the MALs and lifetime members, still have one vote each. But your club has gone from 28 to 70 votes as a result of trying to equalize the relative voting power of independent members versus clubs based on the dues that are being paid. So we've corrected what was a pretty bad imbalance that was created over the years. And we've also tweaked the election process a little bit to prevent the possibility of having to conduct an election at a business meeting, which would be a 5-hour nightmare if we ever had to do it. And it could occur anytime a sole candidate on the ballot dies or is unable to serve, or if there's no one on the ballot, which happened one time in 75 years, but we fixed it anyway. The trustees have also been given more specific ability to use principal from the trust fund, which is growing rapidly because of bequests. And they now have the power to use money to protect critical functions of the league, to pay legal costs, if any, and to take actions necessary to preserve our 501c3 status. We're up to about 23,000 members now, thanks largely to clubs like your own. And so we're pretty happy with that. At this point, I'll begin. The last 2 times I had the privilege of speaking with you, I talked about cosmological topics, but we're not going to do that tonight. We're going to have a little fun tonight. Tonight, we're sort of going to be talking about the Oscars of astronomy, and I'll call them the Edwins in this case. And as Trina said, we're going to be looking at extremes, topics that are, or subjects, I should say, that are unusually large or bright or distant, as she mentioned. So let's start, and we'll go first of all with the coldest place in the universe ever. And that was achieved at the University of Bremen in Germany in 2022 by Christian Deppner and a group of other scientists who published on August 30, 2022. And they reached a temperature of 38 picokelvin, which is a very tiny portion of a Kelvin degree, as you can see here, of absolute zero, using matter wave lensing of rubidium Bose-Einstein condensate, basically draining energy from a Bose-Einstein condensate, which is so cold that the atoms actually merge into a kind of a soup. Next, we'll talk about the largest refractor, and we all know what that is, and still is. It's still the 40-inch F19 refractor at Lake Geneva in Wisconsin, the Yerkes Observatory. The doublet in this telescope weighs 485 pounds. What about the largest reflector using single aperture? And that belongs to the Grand Telescopio Canarias. It has a 409-inch segmented mirror, all in one telescope, which gives it about 4 times the light gathering power of the 200-inch at Mount Palomar. The largest reflector using combined apertures is the Large Binocular Telescope at Mount Graham in Arizona. This telescope uses twin 330-inch mirrors and has a combined effective aperture of 465 inches. Soon, however, in 2025, the extremely large telescope in Chile will go into effect. It will have a mirror, a segmented mirror, 1,547 inches in diameter. That's 129 feet. And that will be something to behold. Next, we want to talk about the hottest place in the universe ever. And that, remarkably, as you may be able to tell, as we talk about these records, we're moving progressively further away from the Earth, but we're still on the Earth as it happens, because the hottest place ever determined to exist in the universe outside the Big Bang was an event at the Large Hadron Collider at CERN, where lead ions were collided at 99% the speed of light, creating a Clark-gluon plasma. They achieved a temperature of 9.9 trillion degrees Fahrenheit. That's about 5,500 times hotter than a supernova core at maximum compression. The worst space-related disaster, well, that occurred back on October 24th, 1960. What you're looking at here is the R-16 rocket, which was a military rocket, a vehicle for delivering H-bombs, that was under the command of a General Nedelin. And General Nedelin was upset because the fully fueled rocket had an electrical glitch on the second stage, and he decided to go out and fix it himself, or at least supervise its being fixed, without defueling the rocket. And he did this because Khrushchev was waiting to celebrate a major event in Moscow and wanted to be able to announce a successful firing of this rocket. Well, as often happens when the boss goes to do something, everybody else has to show interest by joining him. And so a whole bunch of scientists went up to the second stage of this rocket. And as they were tinkering with the electronics, about halfway up the image you see here, it caused the second stage to ignite. And the result was a disaster that killed 92 people, including General Nedelin, and injuring, badly burning 42 others. The largest impact crater on Earth, where would we find that? Well, it turns out it's in South Africa. It's the Verdifort Dome. It's 190 miles in diameter and 2 billion years old. By comparison, the Chicxulub crater from the KT impact is 93 miles in diameter. So this is more than twice as wide. There's some thought that there's a 300-mile crater beneath the ice in Antarctica. That has never yet been confirmed. So as of now, the Verdifort Dome is still number one on that list of astroblems. The largest radio telescope in the world. We have to travel a little bit further to get to it. It's in Jingke Village in Guizhou in China. It's the Eye of the Heavens. Went into operation in 2016, and it's 500 meters, half a kilometer in diameter. What about the oldest astronomical observatory in the world? Well, that is believed to be a Stonehenge-like site at Wurdi in Little River, Victoria in Australia. It's basically an Aboriginal Stonehenge that's believed by carbon dating to be approximately 11,000 years old. The first animal in space. If you're old enough, you might remember the first time you saw Sputnik go overhead. Actually, what you were seeing was Sputnik 2 going overhead on November 3, 1957, and aboard was a dog named Laika. And Laika was also the first spaceflight fatality among mammals anyway. Laika died after 5 hours due to overheating on board the spacecraft. The first man and woman in space, both Russian. Yuri Gagarin, of course, won orbit on April 12, 1961, an event that shocked the United States into a massive space race, even more than the Sputnik launch did. And Valentina Tereshkova went into space for 48 orbits on June 16th through 19th of 1963. The first human spaceflight fatality, again a Russian, Vladimir Komarov, died on April 24th, 1967, as his Soyuz 1 spacecraft was entering the atmosphere. And as it plunged through the atmosphere, the main chute got tangled with the drogue chute. And as a result, he plummeted to the ground without the benefit of a chute. Now, as the impact occurred, which probably killed him instantly, the propellant that was going to fire just before a proper landing would have occurred to basically buffer the landing ignited also and burned the capsule up. And so there was nothing left of cosmonaut Komarov except charred remains as a result of this disaster. There were 203 structural flaws in the Soyuz 1 capsule. And Yuri Gagarin, who was a very close friend of Komarov's, tried to switch and take his place because he believed Komarov would actually die in this mission, and he did, in fact. The Russian government would not allow Gagarin, who was a national hero, of course, to take that risk. The most time spent in space, also a Russian. Gennady Padalka spent a total of 879 days on 5 flights in space. That's 2 years and 89 days of his life he spent in orbit around the Earth. The longest single space mission belongs again to a Russian, Valery Polyakov. He had one mission lasting 437 days, 7,075 orbits, covered 187 million miles. What about the most missions to space? That honor is now shared by 2 American astronauts, Jerry Ross and Frank Chang Diaz. They've both been into space 7 different times each. The previous record holder was John Young with 6. The human speed record. Well, that belongs to Apollo 10, Tom Stafford, Eugene Cernan, John Young. On May 26, 1969, as they re-entered the Earth's atmosphere, they achieved a speed of 24,846 miles per hour, the highest Earth relative speed any humans have achieved. What about the human altitude record? Well, that belongs to Apollo 13 astronauts, Jim Lovell, Fred Hayes, and Jack Swigert. They achieved it on April 15, 1970, when their spacecraft looped around the back of the moon, but did not fall into lunar orbit, hence stayed fairly high beyond the moon on the far side, and achieved a distance from Earth's center of 249,205 miles. And that record has stood for an amazing 53 years. April 15, 1970, of course, was tax day. And if you recall, Mr. Swigert had failed to file his taxes in time and had to get President Nixon to give him a reprieve on that. The first unmanned landing on another world, again, a Russian achievement. It occurred with the Luna 9 landing on February 3, 1966, which snapped this very rough image and sent it back to Earth. The first manned landing, everyone knows that. That occurred July 20th, 1969 at 3:17 p.m. your time in Minneapolis or Minnesota, with Apollo 11 landed. The longest stay on the moon belongs to the Apollo 7, the last of the Apollo missions. And that was a stay of 3 days and 3 hours on the lunar surface. At our recent convention in Albuquerque, we had a chance to meet and speak with Harrison Schmitt, who's undoubtedly one of the friendliest astronauts I've ever met in my life. Very cordial, stayed for a very lengthy period of time talking with people and snapping pictures with anyone who wanted to. And he was, of course, a geologist who was on the Apollo 17 mission, one of the last 2 people to walk on the moon. What about the highest known mountain in the solar system? Everybody says, oh, well, it's got to be Olympus Mons, but technically not. It's technically Rhea Silvia on the asteroid Vesta. It's 72,178 feet above the mean altitude of the surface of the asteroid. That's about 14 miles. It's about 100 meters taller than Olympus Mons. And here's a comparison of mountains. Some on Earth and some on other planets. It might be of interest to you. Here we have Ahuna Mons on Ceres at 13,000 feet, Picard Mons on Pluto at 20,000 feet, Mount Huygens on the moon at 18,000. Earth's Mount Everest stands at 29,028 feet, but amazingly is nowhere near being the highest mountain on the Earth. It's Mauna Kea, which stands 33,500 feet above the seabed. We have also Verona Rupes, which will come up shortly, and Miranda, which is a cliff, 33,000 feet high. Buasola Montes on Io, almost 60,000 feet. The equatorial bulge on the Iapetus, 63,000 feet. Olympus Mons, almost 70,000 feet. Rhea Silvia, just over 72,000. So that difference is more than 100 meters. It's more like 2,000 meters. Well, what about the first unmanned landing on another planet? That honor belongs to the Russians again. This was the Venera 7 mission on December 15th, 1970. Amazingly, as the spacecraft was dropping through the ever denser and ever hotter atmosphere of Venus, some of the cords on the parachute melted. And so the actual lander ended up hitting the surface at 37 miles per hour. Was able to broadcast some images and data for about 20 minutes in the 887 degree Fahrenheit heat of the surface, which of course that transmission transmitted the actual temperature at 887 degrees, and also the fact that the pressure at the surface, the atmospheric pressure, was 90 times that of the sea level pressure here on Earth. That's equivalent, by the way, to being about 3,000 feet deep in water as far as pressure is concerned. So not a very hospitable environment at all. The largest known crevice or canyon, that honor belongs to Valles Marineris on Mars. It stretches 2,700 miles, which is big enough, long enough rather, to extend all the way across the United States from the Pacific coast to the Atlantic. The fastest spacecraft that we've ever had is the Parker Solar Probe. On November 20 of 2021, it achieved a speed of 364,660 miles per hour. It passed within 6 solar diameters of the surface. That would give you an image of the sun that was 8.8 degrees wide. That's about 18 times wider than the image we see here from Earth, and about 310 times larger in surface area. 18 times larger in wider than we see the sun on Earth. Basically, the view from the Parker Solar Probe when it came the closest to the sun would be the same as looking at a big 3-foot beach ball from a distance of about 18 feet. Pretty close. The first asteroid landing was the near Shoemaker mission to Eros, and that landing occurred on February 12th, 2001, when the asteroid was 158 million miles from the Earth. And the landing produced some amazing images of the surface of an asteroid. We've also landed on a comet. The first comet landing was the Rosetta mission and the Philae lander, which of course touched down gently on Comet 67P Churyumov-Gerasimenko. That was on November 12th of 2014. Quite an achievement considering the size of the comet and the very low gravity. The greatest comet impact that we know of was, of course, the great July 18th, 1994 comet Shoemaker-Levy impact on Jupiter. The G impact is the large one that you see here. It had an effective explosive force of 6 teratons. That's 5 million Hiroshimas. To give you an idea of the damage that would have done had it hit the United States, this is the G impact superimposed on the planet. The most volcanically active world we know of is Io, Jupiter's moon Io, of course. It's a constant, the activity there. It covers the surface with new material almost on a regular basis. What you're seeing here is a plume from the volcano Tvashtar, which is producing a plume 190 miles tall. And the New Horizons mission in 2007 is the one that took these images as it winged its way toward Pluto. The largest known impact structure is on Ganymede. Some Japanese astronomers in August 27th of 2020 determined that there was an impact structure on Ganymede that was 4,836 miles in diameter, which is greater than the diameter of the world itself. They estimated that the impactor was 50 kilometers in size and determined its existence by a global system of furrows, some of which you can see right in the middle of the image. What about the largest known storm that we know of? You'd think it would be the Great Red Spot, but you'd be wrong. It's actually the great springtime storm on Saturn that occurred between December 2010 and August of 2011. This storm ended up covering 1.5 billion square miles. That's 8 times the Earth's surface. At one point, it was 9,000 miles in width and covered 186,000 miles in length around the planet's girth. The most distant unmanned landing, of course, was the Huygens lander from the Cassini mission when it landed on Titan on January 14th of 2005. That landing occurred 885 million miles from the Earth. It was rather remarkable because the Huygens lander was actually capable of floating. It was thought that it would land in ethane seas, but apparently the seas are confined to the poles, and the entire area where the lander touched down was very dry. And we have the tallest known cliff. This is Verona Rupes that I mentioned earlier. It is 63,000 feet or 12 miles high. Because of the low gravity of this little 240-mile wide moon, you might think it might be fun to jump off of this, because if you had a 25-foot ladder dropped off the side, it would take you the better part of 10 seconds before you even reach the bottom of the ladder. So you could change your mind and grab the ladder, and you'd be wise to do so, because by the time you completed the 12-minute fall to the bottom, you would have achieved a speed of 124 miles per hour, which is suboptimal. The furthest photo ever taken of your home planet is this photo snapped by Voyager 1 when it was 4 billion miles away from the Earth. This, of course, is the famous pale blue dot photo that Carl Sagan made quite famous. The furthest man-made object from Earth is Voyager 1. Today, it's 14.8 billion miles away. That's 1/2000th of a light year. It's taken 43 years to get there, and if it were headed toward Alpha Centauri, which it's not, but if it were headed to the nearest star system to us, it would take 76,000 years to get there. It's expected to lose power ultimately in 2025, but it's been an incredibly successful mission studying now the heliopause and space beyond the edge of the heliopause. The nearest star to the sun is Proxima Centauri. Proxima, of course, is a red dwarf. It orbits 2 sun-like stars and takes a long time to do it. Its orbit around those 2 stars is 550,000 years. That's Alpha Centauri A and B. The distance to Proxima is 4.25 light years. That's about 25 trillion miles. Which is about 8,330 times further away than Pluto. And the star has a diameter of about 124,000 miles, so you could just squeeze 2 Proximas between the Earth and the Moon to give you some idea of how big it is. If you were on Proxima Centauri, one of its planets, looking back toward Cassiopeia, Cassiopeia would look very much like it does from here. Only there would be 1 extra star here, and that would be the sun, approximately as bright as you see it here. The closest planet, rather, to the solar system outside of our solar system is Proxima b. This is a planet whose orbit is marked in yellow here at the very center of the diagram. There are at least 2 other planets, possibly 2 others, Proxima d, which is still questionable, and Proxima c, which currently is further away from us than Proxima b. And so this is a planet that's in an 11-day orbit around Proxima Centauri. It has about 1.17 Earth diameters in size, and it does lie within Proxima's habitable zone. The only problem is that red dwarfs are flare stars for the most part, and Proxima certainly is, which would make life on the surface of Proxima very difficult. The closest supernova remnant to us is one that we're actually inside. It's about 300 light years in diameter. It's called the local bubble, formerly known as Geminga. It resulted from supernova explosions that occurred between 10 and 20 million years ago in the Pleiades moving group. And here is sort of a rotating view of that bubble. Again, about 300 light years in diameter. The most sun-like star that we've ever found is 18 Scorpii. It shines at magnitude plus 5.5 visual and lies only 45 light years away. We know of no planets around the star so far, but that may simply be because their orbits do not align such that they transit the star. The mass is essentially equal to the sun, its luminosity equal to the sun, its diameter equal to the sun, its surface temperature equal to the sun, its rotation rate equal to the sun, its age almost equal to the sun. So if you want to take a look at a sun-like star, this is your best shot. 45 light years away. What about the largest apparent diameter of a star other than the sun? We know the sun shines, it has an apparent diameter at half a degree, 30 seconds of arc. These are the three stars that have the largest apparent diameters of any stars in the sky as seen from Earth. R Doradus is the winner at 0.05 seconds, 57 seconds of arc. Myra at 0.56, just a little bit below that, and Betelgeuse at 0.46 seconds of arc, compared to Pluto, which has a visual angular diameter of 0.15 seconds of arc. Okay, what about the smallest known planet? Well, that's actually Kepler 37b. It orbits the star Kepler 37 in Lyra, which is 215 light years away. The size of the planet is essentially the same as the Earth's moon, seen here. It's in an 18-day orbit around the star, and its surface temperature is a balmy 800 degrees Fahrenheit. The largest known planet that we know of, also an exoplanet, is the planet HD 100546b in Hercules. It's 320 light years away, and it has a diameter of 607,000 miles. That's about 7 times larger in diameter than Jupiter. There's a possibility it could be a brown dwarf, and there's a fine line between large planets and a brown dwarf. We all know if Jupiter were more massive than it is, it too would be regarded as a brown dwarf. This planet has the density of balsa wood. The darkest known planet is TRES-2b. It orbits the star Kepler-1 in Draco, 750 light years away. It has about 1.25 times the diameter of Jupiter and reflects less than 1% of the light that strikes it. That's a low albedo. The closest black hole to Earth, this is a new discovery, just recently determined that there's a black hole called Gaia BH1 that swings around a host star, which is sun-like in nature. This black hole lies at a distance of only 1,560 light years. And the star and the black hole whip around each other about every 185 days. The black hole is estimated to have a mass of 9.6 times the mass of the sun, and the diameter of its event horizon is about 34 miles. The most symmetrical non-spherical object found in space is unquestionably the red rectangle in Monoceros. Lies at a distance of 2,300 light years. It's a planetary nebula, of course, but look at the symmetry. Very odd to find something non-spherical that has a symmetry quite this perfect. The most planets around a star. Well, that record used to be held by your good friend, the solar system. But we gave that up when we demoted Pluto. And so now we're in a tie with 8 planets. And the tie is between the solar system and Kepler 90, star in Draco that lies at a distance of 2,790 light years. It too has 8 planets. The coldest place in the universe now that the Bremen folks are no longer doing their experiment, is the Boomerang Nebula in Centaurus, about 5,000 light years away. it's releasing gases at over 300,000 miles per hour. And as a result of that, which has an effect not unlike evaporation, is that the temperatures in the Boomerang Nebula are down around 1 degree Kelvin. What about the furthest moon that we've ever found? Is it a moon of Neptune? Actually, no, it's a moon around Kepler 1625, a star 8,200 light years away. What they noticed is that as the main body of the planet moved across the disk of the star, the brightness of the star dropped, but there was an additional smaller drop, possibly because of a following moon about the size, well, a little bit larger than Uranus. And as a result, this would be the furthest natural satellite that we've ever detected. What about the hottest known star, surface temperature wise? This would be a Wolf-Rayet star, 102 in Sagittarius. It lies at, excuse me, I have one slide here to give you an idea of how large that natural satellite Kepler 1625 is. Here's the largest moon in our solar system, and here's Kepler 1625 b1, which is the furthest known natural satellite. Okay, back to the hottest known star, the Wolf-Rayet 102, 9,450 light years away in Sagittarius, has about 60% the radius of the sun. It's right here at the center of the image. And its surface temperature is 378,000 degrees Fahrenheit. That's about the sun's surface temperature, around 10,000 by comparison. The largest known star, well, let's start with the fastest spinning star. That would be PSR J17482446. It's a little dot down here in the yellow square. It lies in Sagittarius at 18,000 light years distance, and it spins at a rate of 716 times per second. It's a neutron star. If I said star, I meant pulsar. And that's about 24% the speed of light at its equator. So this, among stars, is the fastest spinning one known. The reason it's able to hold together at that rate of spin is because of the tremendous gravity of a neutron star, material packed together so tightly. The largest known star is Stephenson 218. This is about 18,900 light years away in Scutum. Has a diameter of 1.8 billion miles, would engulf Saturn. Here's Earth's orbit compared to Stephenson 2-18. The fastest moving star would be S4716. This is in the core of our Milky Way, and it orbits the black hole Sagittarius A star at the core of our Milky Way, which is, of course, invisible here. And you can see the star here as it loops very rapidly toward Periasteron down around the black hole. It reaches about 8% the speed of light when it's closest to the black hole. And this star lies at a distance of 25,640 light years, the same distance, of course, as Sagittarius A star. The furthest known planet, that's an exoplanet called Sweeps 04, lies 27,710 light years away, further than the center of our Milky Way, and it has about just under 4 times the mass of Jupiter. The closest galaxy to the Milky Way is one that's wrapped around the Milky Way. It's called the Canis Major galaxy. Its core is about 42,000 light years from the core of our galaxy, and this was determined to exist by the 2-mass survey. It's being absorbed and is already well absorbed, of course, by the Milky Way following a collision some time ago. The fastest spinning star that's not a neutron star is VFTS 102. It's in the Large Magellanic Cloud, lies at a distance of 164,000 light years, and it has a spin rate of 1 million miles per hour at the equator. That's 100 times faster than the rotation speed of our sun. We're getting further away now. So we'll talk about the largest known spiral galaxy. It's called the Condor. It's NGC 6822 in Pavo, and it's 522,000 light years in length from tip to tip. The largest galaxy, or excuse me, the loneliest galaxy that we've ever found is MCG 0102015 in Boötes. It lies 293 million light years away, and it lies in the middle of the Boötes void. There is no galaxy, despite what you may see in the foreground here, there is no galaxy within 100 million light years of this galaxy. This means that if there were a civilization there that progressed on the same time scale as ours, the folks on that galaxy would not have discovered that other galaxies existed until the 1960s. They would not have been able to see them without the very large telescopes that we had beginning at that era. The largest known galaxy is IC 1101 in Virgo. Lies 1 billion light years away, has approximately 100 trillion stars. That's about 500 times more than the Milky Way. It has a halo that is 4 million light years wide. That would more than subsume both the Milky Way and Andromeda by comparison. M81 has been added to this image by way of scale. The hottest known place in the universe on a constant basis, assuming that CERN is not colliding lead atoms, that honor belongs to a galaxy cluster called RxJ 1347 in Virgo. Lies 5 billion light years away. The temperatures there reach about 300 million degrees Kelvin in a cloud of gas in the galaxy in the lower part of this image. The largest known black hole, that would be Phoenix A. It's a distant black hole of 5.8 billion light years away. It has a mass of 100 billion solar masses. That's about 24,000 times more massive than the black hole at the center of the Milky Way. Indeed, this black hole has more than 2 times the mass of the entire M33 galaxy in Triangulum. The diameter of the event horizon is 366 billion miles. That's 100 times greater than the distance between the Earth and Pluto. It's called a SLAB, which is an acronym for stupendously large black hole. The most massive galaxy cluster known consists of 3 quadrillion stars in multiple galaxies that are gathered together in a cluster called El Gordo, which means the fat one. It lies 7 billion light years away. The furthest naked eye object. Now you may say, whoa, we're already talking about things that are 7 billion light years away, and you said we were moving progressively further. Are you telling me, Chuck, that we're going to be able, or we could have seen something with the naked eye that's further than this? And the answer is actually yes. Had you been lucky and been looking in just the right spot in Boötes on March 19th of 2008, you might have seen a magnitude plus 5.5 star appear and stay above magnitude 6 for about 70 seconds. It was a gamma ray burst. It reached visual magnitude and its distance was 7.5 billion light years in light travel time. I don't know of anyone who actually did see it, but it could have been seen. And so that would have been a record had someone seen it. The largest known structure in the universe is the Hercules Corona Borealis Great Wall. It lies at a distance of 10 billion light years and stretches over a distance of 7 billion light years by 10 billion light years through the sky. It spans 1/9 of the observable universe. And it's a series of gamma ray bursts detected in Hercules, Corona Borealis, Lyra, Boötes, and Draco. The brightest known object in the universe is something that maybe you've observed at your observatory. It's possible. It shines at magnitude plus 15.2 and has the brightness of 12 trillion suns. It lies at a light travel distance of 12 billion light years. This is a quasar APM 08279-5255 in Lynx and is easily accessible to a 20-inch telescope, maybe smaller. It's a heavily reddened object for obvious reasons. Its light's been traveling to us for 12 billion years. getting stretched all the while. This is also the wettest known place in the universe. APM has 148 trillion times all the water in Earth's oceans, and it's all going down the drain of the black hole. A terrible waste, considering that we're concerned here about 5-gallon flush toilets. 4,000 times the water in the entire Milky Way is believed to exist in this galaxy. The furthest known galaxy that we've ever detected was reported just a few months back. It is by the James Webb Space Telescope. This is Sears 93316 in Boötes. Its light traveled time to us was 13.6 billion years. And today it lies at a distance of 35 billion light years. Of course, this is a galaxy that formed, that you're seeing as it was just 200 million years after the Big Bang. Hence, long before stars had a chance to become supernovas and lace the galaxy with heavy metals. So this is a galaxy consisting only of hydrogen and helium, basically, forming metal-free stars, hence stars with no planets. And coming down the stretch now, the furthest distance that we can communicate with in the universe, and that, of course, would be greatly limited by how far back in time we can look in an expanding universe. And that would be a distance of 16 billion light years. Any object at 16 billion light years, if an event occurs there today, the light will eventually reach us many billions of years in the future. And when it does, we will know that object's at 62 billion light years distant by the time we see it. But we cannot communicate with, that is, we cannot get a light signal to or receive any communication from anything beyond 16 billion light years. And that consists of 97% of the galaxies that we see in our photographs. We're seeing old light that's coming in, but we won't see new light that leaves there today. And finally, the furthest distance that we can possibly see is called the cosmic particle horizon. If an object had taken the full 13.8 billion years to get its light to us, the full age of the universe, we would know that object today was at 46 billion light years. And that is the furthest thing that we could possibly say we could see today. And so that's it. Those are the Edwin Awards. Those are the furthest, closest, wettest, coldest, largest, smallest, brightest, and darkest of all objects in astronomy and space travel. If you have any questions, I'd be happy to answer them. Thank you.
Thank you, Chuck. That is awesome. Everybody here is loving the presentation. I honestly like the slab picture, but you know, it's all good. But we do have some questions online.
Sure.
I don't know, John, do you want to read them or do we want people to unmute? Oh, sure, I'm online. All right.
Was my audio okay? I hope it stayed okay.
Yes, it did. I mean, it cut out a couple of times, but nothing for any significance. Let's see.
We're having some storms here. That could be part of the reason. I don't know.
That's true. Actually, I'm not seeing any. John, are you seeing any questions? Okay.
Hi, Chuck.
Yes.
This is Jerry Jones. I'm the AL coordinator at
Yes,
MA.
sir.
We've had conversation back and forth.
Absolutely.
I have one question for you. How many nights of sleep did you lose dreaming up this crazy and incredible list?
Well, it's an interesting program. I've done it for many years, but the problem is every time I give it, I have to research it all again because most of these records change. Probably since I gave it last 4 months ago, I would guess that there were probably 7 records that changed. So you have to stay on top of it before you give it. There's new discoveries that come along, like the coldest temperature at Bremen. That record's probably changed 3 times since 4 months ago.
How long have you been doing this presentation? How many years?
I think the first time I gave this talk was in 1998. And well over probably 60% of these records have changed in that time.
It is an amazing presentation and very fun. I feel as though my brain is going to explode. Thanks very much.
You're welcome. You know, I have an element collection with 92 elements, and I asked somebody to make me a copper ball that weighed 105 grams, and I've got it right here. And I use this because I give this talk on universe scale a lot. And it's kind of interesting because the reason I wanted 105 grams is because 105 grams of copper is 1 septillion atoms. That's a trillion atoms, which is about 3 to 4 times more atoms in this ball than there are stars and all the galaxies within the observable universe. And it's just kind of a fun way to point out that there's an inner universe too that's just as amazing as the outer one. But fun fact. I'm sorry, did I interrupt the next question?
Hi, well, it's actually a good question for now, since you said that you're constantly changing your list and updating your list.
Yes.
Did you hear about the brightest gamma ray burst announcement last week?
No.
They're calling it BOAT, which stands for brightest of all time.
Okay. I'll add it.
October 9th of last year, it was seen in Sagitta. And I don't know, I have an article here. It's 2.4 billion light years away. And even with that distance, it was bright enough or powerful enough to impact onto our ionosphere and actually make an impact.
Wow. Okay. I don't have an entry for that, but I'll add it to the program.
Yeah, it was just a couple of days ago, just in the last week.
Yeah, if you come across any records that I didn't cover, send them along. I'm constantly tweaking it. I don't give the program without checking them all. You know, most of them are pretty safe, you know, like the early part of the program. Some of those are pretty stable. The first lunar landing on another world is not going to change, you know, and that sort of thing. But a lot of them I have to change. The furthest galaxy that we've observed, that record has changed 4 times in the last 8 months.
Wow. What was I just have a quick question on
Yes.
the darkest planet. What was
Yes.
the composition to make it so dark?
As I recall, it was methane, largely methane atmosphere, but I'd have to check on that and get back to you. I can't really recall.
Okay.
I hope I could pitch in some questions too. I just had a couple that I needed answered, if that's okay with you too.
Well, sure.
Yeah. So I was wondering, what do you do and what did you kind of study in college, or what did you just study in general?
Well, I've been studying astronomy since I was 7. In college, well, I'm a lawyer by profession. I majored in political science, took lots of physics and math though along with it. And I probably know a good deal more astronomy than I've ever known about law or anything else. It's just something I pursued with a passion for a very long time.
Oh, and how would you describe your day-to-day work environment?
My day-to-day work environment consists mostly of not sleeping.
Well, I'm very sorry for you about that one.
My league duties are keep me pretty busy. I coordinate 3 league observing programs. Being vice president, I run 8 award programs that have all reached, you know, the deadline on March 31st, and got judges to appoint and getting material out to them. I've got probably 4 Zoom programs I do each month, sometimes more. I travel a lot to give programs if I can. I was hoping I'd be able to come to Minnesota, but I have a company coming this weekend and I have to go to Neve next week, and it just wasn't feasible. But I would love to come up there and see all of you in person. You're a very critical club to us, and one of the most successful clubs in the country. One of the very few that is just active in every possible way: observing programs, observatory maintenance, fantastic membership, a great participatory organization. I also do a lot of observing. In the last 4 years, I've completed 42 of the Leads Observed programs. And I do that by traveling to a dark sky site that's 72 miles from my home. And I've spent 105 all-nighters up there in the last 4 years. So sleep with me is an option. And every time I go up there to do observing all night, my sleep schedule gets totally wrecked. And I also spend a very, very great deal of time talking with a good friend of mine I've known since I was 10 years old, who's Richard Gott. Richard is an astrophysicist at Princeton. He's a collaborator on several books with Neil deGrasse Tyson. Richard and I talk 4, 5, 6 hours a night about every topic under the sun. He's the most fascinating person. As Neil Tyson once said when I hosted Richard's 75th birthday party online, Neil Tyson said, if I had to be chained to a dungeon wall with anyone in the world, I would pick Richard because he'd be the most interesting person they had nearby. So I'm able to pick his brain on lots of cosmological topics and stay up on things, especially with his help.
Lovely. Well, I know we would love to have you in Minnesota. So if you ever get around traveling,
I would love to get up there.
Stop on by.
I'm going to try to coordinate that. Actually, I've got a young friend, 32 years old. He had a paramotoring accident in Rapid City, South Dakota, and lost both hands as a result of the accident. And I would like to coordinate a visit to a club meeting in Minnesota and then just head on over there. So I will arrange that.
That sounds good. I do have a quick question.
Sure.
We have a couple more here. There was Freya once wanted to know more about the fast pulsar and what the name was again.
The fast pulsar. Okay. Rapidly spinning pulsar. Hold on.
And Hazel, if you do have some other questions, we can forward them to Chuck here.
Yes, it's
and have him answer them for you.
Oops. Oh, hold
Thank
on.
you.
It's PSR J1748-2446. That's PSR J1748-2446.
Perfect. I put that in the chat as well.
Okay.
And I believe we do have one more question in house.
Sure.
I just, I can't imagine how you go about measuring the albedo of a planet that is an exoplanet. It seems like an extraordinarily difficult thing to do. Do you know how they did it?
I don't. Part of the problem with giving a program like this is doing in-depth study on each of these topics. That would require a lifetime. I don't know how they did that. And I'd be happy to find out because it's an interesting question.
I'll look it up myself.
Okay.
And then let us know. Yes, please. We can share. We can share. Is there any other questions online or in the house? I do not see any. I don't hear any here. Wonderful. Well, thank you very much, Chuck. We appreciate your time and look forward to seeing you.
Thank you.
Hopefully. Have a great night.
Thank you. Great seeing all of you again. And thank you for the invitation. I love talking with you and I look forward to seeing you in person.
Definitely. Definitely. Well, I thank you everybody for who is ever online. We appreciate you tuning in, and for everybody that's in-house. Thank you. And for those that are here, we can always meet over at Old Chicago afterwards. There's books on the back table that are free to peruse through and pick up and take home, along with the Star Party schedule for Cedar Creek. Have a great night, and we'll see you on May 5th.